Okay. Assalamu alaikum. Just before we get started, just want to confirm that you guys can hear me. And I'll be sharing my screen in a second. You'll be able to see it. Just confirm for me, please. Very cool. Okay, let's just give a few, like 1 or 2 minutes, and then we can begin. Okay, I think we can start. Okay, assalamu alaikum and hello to everyone. Welcome back. Okay, so before we begin, I just want to explain to you guys how we're going to try and structure these classes and just the difference between the two classes. For today, I'm actually just going to be continuing on sequences and series, finishing up the questions, obviously going through some past paper questions, and then obviously those who haven't joined, I'll inform them to watch it later, right? Okay, so I just want to explain what's our objective for these classes. So for the Saturday class, right, I want to make sure that for that class, we can finish every topic on time for examinations. Okay, so whether it means, just say we have a certain amount of weeks in a term, we're going to split whichever topics we need to cover over that time. Okay, so obviously, as you guys can see, with sequences and series, it takes a long time. Okay, it means it's going through like each different example. So in the Saturday class, it's going to focus on getting the basics done, okay, and ensuring you an understanding of how to approach the questions. Okay, with these extra classes, okay, what we're going to do is, number one is, if it permits, we're going to maybe go ahead with work. Okay, so if another topic is taking kind of long, we can use these extra classes to go ahead. Okay, and in that way, obviously, you're not going to fall behind. You can get the topic done in time for whenever you have a test or whenever you need to. The earlier you get it done, the better, right? Going ahead with work, that's an option, right? And obviously going ahead with work will allow us to practice more examples. Okay, so that's another priority of these extra lessons, is to practice examples. Okay, so again, Saturday lesson, cover the basics, introduction to questions. Okay, whereas these extra lessons, right, we basically, we try to cover the entirety of the topic, meaning all the possible questions that they could ask, right? That's our objective. Okay, and with regards to the Saturday classes, we won't be able to do that because obviously because of time. Okay, so we'd be able to do most. However, with these extra classes, we want to really make sure that you understand all the different types of questions. So it would benefit you if you obviously are pushing for an A and you'd like to, because you have to, in order to push to get your A, you need to do past paper examples, because the theory, like just learning the basics of the topic is not just going to help you. You need to be able to put that into practice in the different examples, the different possible examples. And sometimes it actually doesn't help to know 3 out of the 4 examples, because what if they ask the 4th one that you didn't manage to go through, right? So that's the thing for these classes. Yeah, and it's going to be a smaller class for sure, because obviously it is paid. So since it's going to be a smaller class, it might allow for it will actually allow for the opportunity for you guys to answer questions. It may be more interactive. Maybe we can go slower through a question. If you have specific questions that you'd like to do during those lessons, I can go through those questions. And basically we'll be able to interact a lot more. Okay. And yeah, I think that's about it. I'm just trying to think, is there anything else? So yeah, look, the Saturday class, which of course is still going to be free, it's still going to continue, right? That is going to be a class to cover the topics, okay? Make sure we finish syllabus, okay? And do a few questions, okay? When the additional class, right? Just give me 1 second, let me get something out. Sorry, don't mind the noise of my laptop. Okay, is where we go more in depth, right? We do additional past paper questions, and yes, including difficult questions, right? Like those confusing questions that sometimes I feel like it's pointless doing if you don't understand the basics, right? So these classes are to ensure that, listen, basics are covered. Now we go in more depth, okay? Do all the difficult questions, okay? And of course, included in these, when you practice past papers, the more experience you get, the more I'm going to be able to guide you to how to approach these type of questions, right? Then you're going to be more comfortable with, like, you're going to be more confident, because you know that you've practiced like 5 different examples, 10 different examples. So you know that whatever they throw at you, you'll be ready to answer, right? And of course, use it as well to clarify any misconceptions, right? So if you have any questions, again, like I said, it's going to be a smaller class, so it's going to be able to be more interactive, okay? So that's basically the benefits that these classes provide, right? Going forward, we're going to structure it. I'm going to structure it, whereas exactly how I explained, the classes are going to be structured like that going forward, okay? So look, it is of benefit. We're trying to make it as affordable as possible. If you guys do have any concerns now at the end of the lesson, please, even if you have to private message, whatever it is, please contact me or contact the admin to voice any of your concerns, okay? So yeah, inshallah, that's the way we're going to be going forward, and hopefully it is beneficial for everyone. Yeah, I think obviously, so now we started with sequences and series. So this topic is obviously slightly different, but when we get into the next topic, it's going to be about a lot more structured according to how I just explained. Whereas in the Saturday class, again, basics, questions, we aim to finish the syllabus there, right? Our goal is to, by the end of that time, we need to finish syllabus just so that we can cover everything for everyone, right? And when it comes to the Saturday classes, when it comes to the additional classes, it sort of relieves that stress of the time concern, because we have additional time. We can, if someone wants to go through something a bit more slower, if someone wants to do a certain question, it allows for that, right? It alleviates a bit of stress from us because we are allocating more time towards it, okay? So yeah, that's our intentions. That's what we have in mind going forward. And hopefully from like next week's classes, we will be able to commence with that, okay? So for today's lesson, okay, what I am going to do is I'm going to finish up Sigma, okay? So obviously, normally, like I said, it will be structured differently from next week, but I will, for those who aren't here, I will inform them that they need to watch this lesson to complete the rest of the topic, I guess. And as we're doing question, I'll explain to you guys also like what type of questions that there'll be the advantage of the additional classes, right? What type of questions we'll be answering and so on and so forth, right? So yeah, so for today, I'm just going to finish up this topic and do some hard questions, right? And And in this lesson as well, I'll show you some hard questions that would most likely only be done in the additional classes. Okay, cool. So please, if you guys do have any questions, please let me know. And yeah, let's continue, right? Okay, so we ended off the previous, just like earlier today, just going through sigma. Okay, we discussed what sigma is. Okay, we discussed just the basic explanation of it. Sn, okay, summing sigma, we said is sum, okay, and what they give you around the sigma symbol, okay, and how to read it, how to understand it, how to evaluate it or calculate the value. Okay, sometimes it doesn't seem like a question, but that is the entire question. They don't need to give you more information. Like, for example, they tell you to evaluate this sum, okay, and that's what it means. It means calculate the sum of the first 3 to 7 terms, not first, but the terms from 3 to 7 of this pattern, and then they give you Tn next to the sigma symbol. Okay, so we discussed calculating number of terms as well. Okay, so let's move on. Right. So let's have a look at this question. It says write the following in sigma notation. So this is also good for us to know how to write sigma. It helps. So firstly, when it comes to sigma, right, we need to remember, we need the last term. Okay, let's call it A. We need the first term. So in this case, we're not given specific, so we can just call it 1, 2, 3, and then we need to find out what that is, right? So we're going to say n is equal to 1. We start at 1, and we need Tn. So in order to write it out in sigma notation, we need the following. Okay, so let's do that. Remember, all the first step to all sigma questions, okay, is to write out the first 3 terms. Okay, so we have term number 1, which is, okay, we actually have them to, okay, in this case, sorry, obviously in this case, it wouldn't be the case because we do have the first 3 terms. So we actually, in fact, we have A, okay, I'm not going to call this A, that is silly. We'll just, I don't know, what do they generally refer to this as? Let's just refer to it as L, last term, okay? N is equal to 1 and Tn, of course, we said 1, 2, 3, and we need to figure out what is the last term. So we actually have the first term, okay, A is equal to 2, right? Now we need to figure out, is it arithmetic or is it geometric? Okay, the way we're going to figure that out is by doing that minus that. Okay, so if we say T2 minus T1, that's going to give us 8. T3 minus T2 is going to give us 40. 10 minus 2, and then 50 minus 10. So this is not arithmetic, so we have to try for geometric. So not arithmetic, right? Let's try for geometric. Let's say T2 over T1. That's 10 over 2. That's 5, right? Let's try T3 over T2. That is equal to 50 over 10. And that's 5 as well. So now we've analyzed and we've said that it's geometric. Okay. So we know that R is 5. Okay. We know that the value of R is 5. So that's how you eliminate. That's how you decide, okay, is this arithmetic? Is it geometric? And you take it from there. So the reason we needed to calculate R, okay, was simply due to the fact that we need to calculate N for the last term. If we want to calculate N for the last term, we need Tn. So in order to get Tn, in this specific case for geometric, it's A times R to the N minus 1. Okay, so we know the value of Tn because we know it's the value of the last term, 781,250, which is equal to A is 2. Okay, times what is R? R is 5, right? We just calculated it. So that's exactly why we needed to calculate R, because we need to utilize this formula to solve for N. Okay, N minus 1. Okay, so we have 2 times 5 to the N minus 1. Remember, you cannot change this to 10 to the N minus 1 because they are different terms and the 5 has its exponent and we need to sort out its exponent first. Okay, it's a separate, 2 separate values. So what we're going to do is 2 is multiplied on the right-hand side. So we're going to take it over to the left-hand side and divide. We're going to say 781, 250 divided by 2. Or alternatively, if you use divide both sides by 2, we get 390,625 is equal to 5 to the n minus 1. Okay, remember there's 2 ways to solve. Number 1 is the first thing that we need to note, okay, is that when we have unknown exponents, we always want to write both sides with the same base. So we basically want to write this side as 5 to the power of something. Okay, how do we do that? 2 methods. One is log, which we're not going to do. We're just going to utilize shift fact. So 390,625 equals shift fact. And it gives it to you as a exponent. So it changes. This becomes 5 to the 8 actually is equal to 5 to the n minus 1. When the bases are the same, you can drop them. Then you have whatever's left is 8 is equal to n minus 1. Take 1 over, n is equal to 9 basically, right? I'm just swapping it around. So, where were we? Okay, so then write the following sigma notation. So now we know that the last term is 9. N, the last term of this pattern is 9. So when we are writing out our sigma, okay, we are going to put 9 on top. N is equal to 1 at the bottom. And Tn, did we solve for Tn? Not exactly, but kind of. So I'm just going to write Tn is equal to what is A? 2 times 5 to the n minus 1. So technically we did solve for Tn. We just didn't like write it out in one step, but that's Tn. Okay, because we solve for A and we solve for R. So that's going to be 2 times 5 to the n minus 1. And that's going to be our final answer for the sigma notation. Writing it in sigma. Doesn't matter when you swap to the other side or what. Okay, I'll explain it in a bit. So basically like, okay, let's just re-look at it. So I'm going to get rid of this. Let's do it like regularly, right? So what you would do is you would take 1 over and it would become 8 plus 1. And then n is equal to 9. So n is equal to 9 is the same as, 9 is equal to n is the same as n is equal to 9. So it doesn't matter in this specific case, right? You just want to make sure that I didn't change the value. I'm just swapping the equal to sign. I'm writing one on the left. I'm writing one on the right. As long as I take everything that I had on the left and put it to the right and everything that I had on the right and put it on the left, it's fine, right? So for example, if I have 5x plus 6 is equal to 7 plus 9y, for example, I can take this over and I can write it as 7 plus 9y is equal to 5x plus 6. Like, you see, I think what confuses, or what gets confusing is the fact that you're taking it over to the other side and you think that you have to change the sign. Okay, I understand that confusion and it makes sense why it can be confusing. However, all you need to think is that you're just taking this to the other side of that and this to the other side of that. You're just swapping what's on either side of the equation, right? If x is equal to y, then y is equal to x. There's no difference. Okay, provided that I swap both, then I don't have to change the sign. If I'm just swapping 1 and 1 at a time, then I have to change the sign. Okay, when I mean both, I mean when you're taking all of this to the other side, you have to take this also to the other side for you to not swap signs. If you just had to take 1 over to the other side, so for example, 5x plus 6, and I want to bring all of these guys over, yes, then I would have to change the sign. That is different. And it would equate to 0 what's left on the right hand side. Okay, that is different. In this case, you just 9 is equal to n is equal to 9. Okay, it's more preferable to write it out as n is equal to 9. 9 is equal to n. Looks weird. Okay, let's have a look at this. All right, determine the following. Okay, so again, determine the following. That doesn't even look like a question, but all they are asking you to do is, I see an infinity, so I should actually know and I should realize, since I see the infinity, okay, what it means is they basically want me to calculate sum to infinity. That's all. I need to be able to, they actually gave me Tn. Perfect. They gave me Tn. Okay, I need to get, remember, sum to infinity, what is its formula? Sum to infinity is equal to, I don't know, 1 minus r over a or something. A over 1 minus r A over 1 minus R. Okay. So in order to calculate like the main thing here, you need to understand, okay, they're asking sum to infinity. Like, you need to not confuse yourself with the sigma. Okay. You just need to understand, okay, the sigma means that I need to calculate sum to infinity. Okay. How do I do that? Sum to infinity formula. What are my unknowns in sum to infinity formula? A and R. Okay, cool. So now I need to substitute values. So in this case, I don't have A, I don't have R. In this case, when the terms are not given, step number one is always write out the first three terms. We have Tn. So how would you write out the first three terms? They want us to start at 1. So we're going to start at 1. We're going to substitute n as 1. The variable that's in Tn is always this variable, by the way. So n and n is always match. Okay. So I start off by 1 by substituting 1. So 10 is equal to 2 minus 1. Okay. 2 minus 1 is 1. So 10 to the power of 1 is 10. 10, 2 minus 2, because after 1 comes 2. 2 minus 2 is 0. So that's 1. Okay. 10 to the 2 minus 3. So 2 minus 3 is now negative 1. 10 to the power of negative 1, 0,1 or 1 over 10. Okay. So they want us to calculate sum to infinity. Now, in this case, I have A. Okay. A is equal to 10. My first term is equal to 10. R is equal to T2 over T1. Okay, it's definitely geometric, so we don't have to do T3 over T2. We know it's geometric because sum to infinity only works with geometric anyway. And this is going to be equal to 1 over 10. So R is basically 1 over 10. So A is 10, R is 1 over 10. Okay. Thereafter, what we now need to do is okay, we need to substitute into the formula. So S infinity, okay, is equal to A, which is 10, divided by R, which is, no, sorry, divided by 1 minus, we need to write 1 over 10 or 0,1, same thing. You put this in your calculator, 10 over 1 minus 1 over 10. It gives you 100 over 9. So the sum to infinity for this question is 100 over 9. Okay? Cool. Right, let's move on. Let's do this question. Okay, so they say again, determine the following. So it's like evaluate, okay? So again, remember, sigma means sum. So they want us to calculate the sum. The sum of what? Okay, we need to start at 4. We need to end at 18. Okay, and that's our Tn. Now, to me, I know this looks like a arithmetic, I can see, because arithmetic, okay, has a single variable, no square to it. Quadratic will have a square to its variable. And exponential will have a variable in its exponent. Okay, so this is linear. You can check it by doing T2 minus T1 and T2 over T1 and see if they equal. T3 over T2. And then you need to see if this is equal to T3 minus T2. And if you're aware that it's linear, it's linear. Now, first things first, first step when I'm not given the values, step 1 is I need to write out the first 3 terms. So my formula is given, Tn is given, 2 minus 5 into 4. I don't start at 1 because remember the bottom number is the starting number, which is 4. They want us to start at 4 this time. So 2 into 4 minus 1, 2 minus 20, that's negative 18, right? 2, then we have 2 minus 5 into 5 this time, because after 4 comes 5, right? We're always going in intervals of 1, of course. 2 minus 25, that's negative 23. Then number 3, okay, we have 2 minus 6 times 5, sorry. Two minus 5 times 6, 5 times 6 is 30, 2 minus 30, negative 28. Okay, so now we can calculate D, remember arithmetic, eh? T2 minus T1, which is equal to negative 23 minus minus 18. Okay, which is equal to -5. So we know that the difference is -5. Then we can talk about A, which we know A is equal to -18. So now we can solve. Okay, they want us to calculate the sum. Oh, one more thing, we need to get the number of terms, eh? Okay, I'm not going to do that, whatever, I'll just circle it. The number of terms can be calculated by the end term minus the start term plus 1. So basically 15 terms in this pattern from the 4th to the 18th term are 15 terms. So now we can calculate. Okay, let's just write out Sn is equal to n over 2, open brackets 2a plus n minus 1 times the difference. So we need to calculate what? S15. S15 is equal to 15 over 2. 2 into a is -18 plus n minus 1. What is n? N is 15 because we are doing 15 terms times the difference. The difference is -5, we said. Okay, you can put that all into your calculator. Essentially, you are going to get n over 2 -36 plus 14 times -5, so minus 14, no, 70. -36, that's -106, and then 15 times that. 1 time, 2 goes there, 53 times. So your answer is like negative 730 plus. I think it's like -795. Okay, let's just put all in our calculator and get it. 15 over 2. 2 into -18. If those are doing it along with me, please check it for me. Okay, -795. So the sum, basically, we've evaluated the sigma, which was asking us to calculate the sum of these 15 terms. Which 15 terms? From the 4th term to the 18th term. Okay. Let's move on. Let's have a look at this question, which we were going to look at earlier, right? Consider the geometric series. Okay, so they tell us that this is a geometric series, right? It's a geometric series where that, so sigma Tn infinity is equal to okay, that's stuck. Okay, so consider geometric series where that sigma, okay, and S3 is equal to 26. Okay, calculate the constant ratio of the series. Okay, so very strange question. Nothing is given like how it regularly is. It's a backwards question, right? We have to work from the back. We have to write out the formula and substitute what we know. So first, let's evaluate the sigma, the sum. So they say Tn, okay, so this is really important, right? When they put it like this, they say Tn is equal to, it's actually not Tn, this whole thing, infinity, so sum to infinity, starting at 1. Tn is the formula. So actually, in this case, they're not saying Tn is equal to 27. Tn is just not known. We don't know the general formula. They are saying that this entire thing is equal to 27. So this is basically telling us, okay, that sum to infinity is equal to 27, which is basically telling us that 27 is equal to a over 1 minus r. Okay, does that make sense? Okay, that's what they're telling us. So that's the first equation that we write out. 27 is equal to A over 1 minus R. Okay, a little bit of a strange question, but nevertheless. Now, S3, okay, so that's one bit of information. So from this bit of information, what we do notice is we don't know A, we don't know R. At least if we knew A, the first term, we could easily get R, okay, but we don't. So that's all the information we can get from that part. Now let's look at the second part. S3 is equal to 26. It tells us that the sum of the first three terms is equal to 26. Remember, sum to infinity, sum of geometric is just S3 or Sn. Sn is equal to A into 1 minus R to the n divided by 1 minus R. So in that case, I can say sum to 3, which is actually given as 26. So I say 26 is equal to A, which is unknown, 1 minus R, which is unknown, to the power of n, which is known, it's 3, divided by 1 minus R, which is unknown. So here we have two equations with two unknowns, okay? Not 3 here, it's just R and R are the same. So two equations with two unknowns. So what we're going to do is we are going to isolate a variable. We're going to solve simultaneously, basically. Okay, so this is like a simultaneous question, but you see how much harder they can get. Okay, it's like algebra that they testing here. If you compare it to like a arithmetic simultaneous question, those are a little bit easier actually, right? So in this case, I'm going to isolate A here, and 27 times 1 minus R is equal to A. Now I'm not going to open this up because I can see a 1 minus R there, so it might be able to cancel. So A here, wherever I see A, I'm going to substitute that. So there's one A there, it's going to go into that. So when I substitute into this equation, I get 26 is equal to 27, 1 minus R, that's done, times 1 minus R cubed, all over 1 minus R. Now, as you can see, 1 minus R, 1 minus R is common, okay? And we can cancel them. Okay, then we continue. So I'm actually going to take, okay, let's just write it out. 26 is equal to 27. What are we left with? 27, 1 minus R cubed. So I'm going to take 27 over, I get 26 over 27 is equal to 1 minus R cubed. Now I need to take 1 over, right? So I need to say 26 over 27 minus 1. I get negative 1 over 27. I'm leaving it as a fraction because the decimal is irrational. It's continuing forever. Negatives and negatives on either side cancel. And now I'm left with R to the power of 3 is equal to 1 over 27. So I'm going to obviously now remember, in this case, right, we have an unknown base. So we want to write both in terms of the exponents. Okay, so we want to write both with the same exponent, rather. We want to write both with the same exponent. So we can try our shift factoring, actually. It might give us that 1 over 27 is 3 to the power of something, right? When I do shift fact for 1 over 27, if you've tried it, you'll notice that you'll get an error. Whenever your number is in the denominator, okay, bring it to the numerator, basically, or alternatively, you can just try this value, shift fact the denominator, so 27 shift fact. Okay, it's not a fraction. It's going to give you 3 to the 3. So 1 over 27 is 3 to the 3. So, sorry, 1 over 27 is equal to 1 over 3 to the 3. And now you bring this guy to the top. So it's going to become 3 to the negative 3 is equal to R cubed. Okay, remember, when we take it to the top, the exponent becomes negative. So we bring it to the top, 3 to the negative 3 is an unknown variable. Okay, we could negative 1, make it negative 3. Yeah. Okay. So what we could actually then do is, I think is a simpler way. Let me look at it. It's a past paper. Okay, so basically, 3, you could separate it to, because obviously our bases, I mean, our exponents are not the same currently. Okay, so we want them ideally to be exactly the same. Now, what you could do is 3 to the negative 1 times 3. Okay, it's equal to r cubed, of course. And then what you want to do is, remember the power to the power, so you can take this backwards. Oh yeah, true. I don't know why I'm complicating it. Thanks for that. True. You could just cube root both sides. That makes more sense. Sorry. Overcompensation much. Should have stopped me a long time ago before I went down this whole rabbit hole of exponent and surd rules. Okay. Okay, but nevertheless, I'm just going to continue here. So what you're going to do is, you can power to the power rule, right? Just for revision of that, you can bring this down to the that and blah, blah, blah. So then you now get 1 over 3 to the 3 is equal to r cubed. Cancels, r is equal to 3. Your common things cancel, r is equal to 3. Alternatively, if you had a brain, you could have cube rooted both sides. When you cube root both sides, you get r is equal to 1 over 3. Okay, sorry, but yeah, that makes sense. Okay, so yes, another example. Just using sum, using sum to infinity as well as just sum. Okay, simultaneous. Let's look at the next question. Okay, let's do this basic question, right? November 2021 paper. So we're going to do this. It has it's a geometric and has an unknown x. Let's work through it, right? So, given the geometrics, it is x plus 90 plus 81. Okay, calculate the value of x. Okay, so that could be simple because we could utilize r. Let me get the memo. Because we can use r, okay, sorry, because we have this T1, T2, T3, okay? So we can say that T1 over T2 is equal to T3 over T2, okay? And then solve algebraically. So basically, x over 90 is equal to 81 over 90. Cross multiply, 90x is equal to 81 times 90. Divide both sides by 90, x is equal to 81. No, I did something wrong. Okay, I think I know what I did wrong. T2 over T1 is equal to T3 over T2. T2 is 90. Sorry, that's what was wrong. T1 is x is equal to 81 over 90. Now we cross multiply. Okay, we get x times 81 is equal to 90 times 90. Okay, when you simplify it, you get an answer of 100. X, the value of x is 100. Okay, so in that case, what are we just using? We are using TR, okay, because we have 3, right? It's similar to like common difference. For example, if this was arithmetic, you'd calculate what change did they do to go from 90 to 81, and you do the same change backwards from 90 to go back to x, right? So in this case, you're just working with r because we know that it's a common ratio. Let's look at this one. Show that the sum of the first n terms is equal to Sn is equal to 1,000, open brackets, 1 minus 0,9 to the power of n. Okay, so just utilizing the information that we have so far. Remember that, okay, I'm just going to work here. Sn is equal to a, open brackets, 1 minus r to the n divided by 1 minus r. Sn is equal to, what is our first term? We calculated x as 100. So 100 into 1 minus, did we calculate r? Well, we technically didn't, but we can simply just say T2 over T1. So T2 over T1, which is equal to 90 over 100. So you can leave that as 9 over 10. Alternatively, because they have a decimal in the question, I'm going to convert this to a decimal of 0.9 and then make it 0.9 to the power of n. Okay. Then we have 1 minus r, which is basically 1 minus 0.9, which is 0.1 actually. So when we simplify this, actually this gives you 0.1, 100 divided by 0.1 is 1,000. You got 1,000 into 1 minus 0.9 to the n. Okay, so we've proved it. Let's look at 2.3, hence or otherwise, calculate the sum to infinity. Okay, sum to infinity. Sum to infinity is equal to a over 1 minus r, which is equal to 100 over 1 minus 0.9, which is 1,000, I think. Okay, sum to infinity. Okay, very easy set of questions, to be honest, nothing too complex. Let's have a look at question 3. Consider the quadratic number pattern. Okay, so just revision of like a few different ones. Okay, I remember we did this one last time already, right? So quadratic, and then we covered the concept of maximum. Okay, maximum value of quadratic. Remember, it's just like turning point. Okay, so let's do this. Second last question. Consider the quadratic number pattern -145, -122, -101. They're telling us it's quadratic. How nice. So we calculate the first differences between each term. When to go from -145 to -122, we actually add, put a plus if you like, 23. To go from -122 to -101, we would have to add 21. Okay. Thereafter, to go from 23 to 21, we have to subtract 2. Okay, so this easy first question for 1 mark, when they say calculate the value of T4, you should have to simply follow this up, right? So I need to go from there. I need to go from there to the next term. I need to go from there to the next term. And I need to go from this first difference, right? From this first difference to the next, yeah. And how do I get there? By minusing 2 again. So how do I minus? I need to minus 2 from 21, which becomes plus 19. Then I say -101 plus 19, and I get an answer of -82. Okay, hope that makes sense. -82. All right, cool. Let's move on to the next one. Show that the general term of this number pattern is Tn is equal to -n squared plus 26 and minus 170. Please remember the following. 2a is equal to second difference. 3a plus b is equal to the first difference. And a plus b plus c, this is not given in the formula sheet, you need to memorize it, is equal to the first term. The 2a is equal to the second difference, so we will say 2a is equal to -2. Therefore, a is equal to -1. Then we're going to say 3a plus b is equal to the first difference, which is 23. Okay, we substitute our value. So 3 into -1 plus b is equal to 23. Take 3 over, it actually becomes -3 on the side. So on the right side, it will be plus b is equal to 26. Okay, and then a plus b plus c is equal to the first term. The first term is actually -145. We solved for a, we solved for b, so we can sub those in. -1 plus 26 plus c is equal to -145. Take it over, you get 144 minus 26, 170 negative. Okay, we get an answer of C as -170. So we've solved for it. Therefore, since we solved for A, B, and C, therefore, Tn is equal to negative an squared, sorry, negative n squared plus 26n minus 170. Okay, so that's quite simple. Okay, let's look at 3.3. They say, between which two terms of the quadratic number pattern will there be a difference of negative 121? Between which two terms of the quadratic number pattern will there be a difference of negative 121? Okay, so let's just go back quickly to our quadratic notes. And remember this, okay? So remember, here's our quadratic 1, 7, 19, 37, blah, blah, blah. We found the first differences and the second differences. You could solve. Okay, you could then solve for the general term of the quadratic, right? Since you have all of these things. Now, however, what we do need to note is that the first differences form an arithmetic sequence. That's extremely important. And then the second thing was that the first difference is actually the difference between the first and second of quadratic. And the second first difference is the difference between the second and third of quadratic. And the third first difference is the difference between the third and fourth of quadratic. That was really important to note because they ask those type of questions. It's always, if you want to know, like for example, which difference in the quadratic is the difference between T5 and T6 in quadratic, it would definitely be the lower one, T5. Okay, so that's important to note. So let's go back to our question. So they want to know between which two terms of quadratic, will there be a difference of negative 121? Okay, so firstly, you need to know that this negative 121 is a first difference. Negative 121 is the first difference. Okay, it's a first difference in a quadratic pattern, in our quadratic pattern right here. Right? So for example, like 23, 21, 19, right? Until eventually at some point it gets to negative 121. Okay, so that's what they want to know, between which two, right? So for example, 21 is the difference between T2 and T3 in quadratic. And it's the second term of arithmetic. Basically, if we know the position of the first difference, we know between which two terms it would be the difference in, because if the position of the arithmetic is the third position, okay, if the position of the arithmetic is the third position, so for example, T3, then we know, okay, we had the value of 19, we can substitute it into the arithmetic formula, we get n as 3. Okay, so we know, okay, this is actually the third term in arithmetic, and it's therefore the difference between the third and the fourth term of quadratic. So that's essentially what we have to do. We have to calculate which n, what's the n for negative 121 in the arithmetic, which term is negative 121. So let's do that. Okay, let's do that. So we have to get the general formula for arithmetic. So remember, Tn is equal to, what is it? A plus n minus 1 times that difference, right? So Tn is negative 121 is equal to A. What is A? Our first term, which is negative 145. Nope, my head. It's not the first term of the quadratic, it's the first term of the arithmetic. Remember, we are calculating. So the first differences, which is arithmetic, first differences, arithmetic. So we are working with the first differences. Okay, and we're going to calculate the position of this first difference. So we know that which difference in the quadratic is it between. Okay, I hope that makes sense. Yeah. Okay, so 23, I think we said, plus n minus 1 times the difference is 2, negative 2. I think negative 2. Okay, and you actually get on the side negative 25 minus 2n is equal to negative 121. Okay, Now we solve for n, you take it over. Okay, let's take it over minus. That's minus 146 is equal to minus 2n. Negatives cancel. N is equal to 78. No, 73. So basically, between which two terms of quadratic will there be a difference of negative 121? Okay, we know that negative 121 is the first difference of a quadratic. In the first differences of a quadratic, we have an arithmetic sequence. Okay, now in that arithmetic series, in that arithmetic pattern, the 73rd term of arithmetic is negative 121. So if the 73rd term of arithmetic is negative 121, can somebody tell me between which two terms is this the difference of? This. Between which two terms in the quadratic is negative 121 the difference of? If we know that negative 121 is the 73rd arithmetic first difference, between which two terms? T73 and T74, excellent. Okay, anyone disagree? Okay, let's put this to charge. Okay, let's move on to the next one. So, what value must be added to each term in the number pattern so that the value of the maximum term in the new pattern, in the new number pattern formed will be 1? Okay, so a lot to digest here. Short question, but a lot to digest. What value must be added to each term? That's what they want to know in the number pattern so that the value of the maximum, okay, so they want to, the value of the maximum is going to be 1. The new maximum is going to be 1. That's what they're saying. So let us calculate the old maximum first. Okay, so remember the maximum is basically like turning point from parabola. So I don't think you guys have done calculus yet, but you can actually derive it and equate to 0. You'll get there. But basically, we find turning point x. TPx is going to give us, actually, it's like TPn almost, because here instead of having x, we have n. Okay, it's going to give us the term. It's going to give us the maximum term. So maybe it's going to tell us it's the 50th term. That's the maximum. Okay, it's equal to negative b over 2a, which is negative 26 over 2 times negative 1, which is basically positive 13. So actually the 13th term, we forgot to answer this question, T73 and T74. Okay, so we know that the 13th term is the maximum. Okay, now we need to calculate what is the value of the 13th term. We just sub it into that equation. So negative 13 squared plus 26 into 13 is going to give us the value of the maximum. And we get an answer of negative 1. Okay, so T13, which is the old maximum, the maximum of the old pattern, is negative 1. So the old maximum, keep in mind, is negative 1. They want the new maximum to be 1. Okay, and then they want to know, okay, so what's the difference between the new max and the old max? 1 minus minus 1, it's 2. Right, so 2 was added to the old maximum to get the new maximum. So what value must be added to each term so that the value of the maximum in the new pattern formed will be 1? So if you're going to add 2 to the maximum, you could add 2 to every single term in that pattern, and the maximum would be 1. Okay, does that make sense? So because you don't want to add, like, you can't add 3 to each term, because then it's gonna make the maximum bigger than 1. They want the maximum to be 1. Sorry, new max must be 1. So how do we get from negative 1 to 1? We have to add 2. And then if you add 2 to each term, it would keep the maximum as 1. Okay, so what value needs to be added to each term? 2. Okay, let's move on and let's quickly do this last one. Okay, we're going to finish it. So firstly, consider the linear pattern 5, 7, 9, blah, blah, blah. Determine T51, no thanks. Calculate the sum of the first 51 terms, no thanks, right? Those are easy questions. Look at the hard question, okay? 4.3, okay, and 4.4, okay? I think many people have cried looking at this question. So let's see how not to cry while doing this, while attempting this question. So sigma, okay. Whenever, even if this question was ignored, actually, let's ignore that question just for the sake of learning, okay? If we have to look at something like this, okay? Solve or calculate the value of that monstrosity, okay? But okay, let's break it down. We're able to break it down since we learned sigma. So sum, we know that this is the sum. It's a linear pattern. You can see from the Tn, okay? So we have Tn, right? The sum of the first 5,000 terms, basically from 1 to 5,000. Obviously, like, geez, man, that's a lot of terms. That's going to be tough to calculate. Then they say the sum of this one, a new pattern, right? With Tn formula as well, okay? And then it's the sum of the first 4,999 terms, basically, right? With Tn. So whenever you have these big questions, okay, what you want to do is you always want to draw out at least, okay, you might need to draw more, the first 3 terms, 1, 2, 3, and the last 3 terms from the back, because we know the final value. So you want to draw out your first 3 terms, right? So that's simple because I need to start at 1 and I know Tn. So let's work step by step, right? So I'm going to work with this one first. So I'm going to have number 1 as 2 into 1 plus 3. Now 2 into 1 plus 3, that is, what is that? That's 6, right? 6? No, that's 5. Okay. And I'm going to work on number 2, which is my second term. 2 into 2 plus 3, that's now going to be 7. Okay, so this is the first pattern, eh? Okay, then we have 2 into 3. 2 into 3 plus 3. And that gives us 6 plus 7 is 9. Okay, so that's the first 3 terms. I'm going to say comma, dot, 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 dot. Continue again, comma, and do the last 3 terms. Let's just give us some space. Okay, let's do the last 3 terms. So now remember, the last 3 terms are going to be 5,000 and backwards. So 2 into 5,000 plus 3, that's going to be 10,003. 10,003. Okay, look, you might be like, damn, that's a big number, but don't panic. Okay, literally take it step by step. You know how to approach these questions with the basics, right? The basics are fine. So don't let the big numbers confuse. Just keep doing the basics. Okay, and that's correct, 10,003. Let's do the second last number. So we're going to have 2 into 4,999 plus 3. We don't even actually have to calculate it since we know the difference is 2. We're adding 2 each time. This is going to be 10,101. Sorry, 10,001. And the third last one is going to be 10. No, it's actually going to be 9,999. Okay, keep in mind, they want us to add all of these together, eh? Want us to add. So this is the pattern. I've just represented that pattern. Okay, I put it down and I've tried to just express first 3 terms, last 3 terms. And I'm going to put a big plus sign in between because they want me to add it. And I'm going to work with the second pattern. So let's work with the second pattern, right? The second pattern, let's calculate its values. So negative 2 into 1 minus 1. That gives me an answer of negative 2 minus 1, negative 3, I believe. Okay. Then I'm going to calculate number. Why did I? Okay, that's fine. Negative 2 into 2 minus 1, that gives me negative 5. Then I'm going to do 2 into, negative 2 into 3 minus 1, and that gives me negative 7. Okay, dot, dot, dot. Let's do the last few terms. So I know that they are increasing by 2. Sorry, they are decreasing by 2 each time. Okay, so let's get the last term, which is going to be negative 2 into 4,999 minus 1. Negative 2, open brackets, 4,999 minus 1. That actually gives me an answer of negative 9,999. Since I'm decreasing in each time, yeah, I can increase and get closer to 0. So negative 9,997 and negative 9,995, I believe. Just confirm these. Negative 9,997 and then substitute 7 and we get that. Okay, sorry, just give me 1 second. I'll be with you right second. Okay, so yes, now we have broken it down. Let's have a look at it, right? So remember, we are adding these two together. Now, if you look carefully, you will see some common occurrences in both patterns. Okay, so firstly, we see that 5, remember we're adding, plus minus 5, that's going to cancel. Then we look again, we see, okay, 7 minus 7, that's also going to cancel. And then obviously the way this pattern continues, right? Okay, let's just do that in the same color because that does not look fine. As this pattern continues, we're going to have 9, 11, 13, 15, and so on. And as this one continues, we're going to have negative 9, negative 11, negative 13, and so on. So they're all going to cancel, literally. This is going to cancel with negative 9 at some point, and they're all going to cancel all in between up until where? Okay, so I'm going to start here because I see 999, negative 999. Obviously, this is less. Before 999, there's going to be 9997 and 9996. And those are also going to cancel. So it actually carries on. All of them in between are going to cancel with all of these in between. And we only left with what we can see. So we left with negative 3, 10,001, 10,003. So it essentially becomes 10,001 plus, because remember it's sum. So even within its own pattern, you are summing it. So technically these should be like plus signs, but it's fine, right? So 10,001 plus 10,003 plus negative 3. And that gives us an answer of 20,001. Okay, so a scary question, but can be made to look easy. In this one, technically, you can also use your sum formula. Okay, if you use your sum formula, that would work out as well. But it's not possible for all these type of questions. What kind of better approach is to have? This is a better approach to have, where you break it down and you just analyze it, and you draw the first 3 terms, you draw the last 3 terms. Okay, obviously, the more you practice, the faster you're going to get at it. Okay. So yeah, that's basically the pattern that you identify. Again, you could do also calculate the sum of each one utilizing the sum formula. Okay, get those massive values, subtract them, because technically you add them, and this other one is going to give you a negative answer, and then you would get that answer as well. Okay, cool. So let's see, maybe we'll do another Sigma one at some point, but yeah, cool. So thank you guys so much for joining. We'll obviously be communicating with you guys with what's happening with regards to the classes and all of that. And again, if you have friends who are in this course, tell them that they need to watch this lecture to complete sequences and series, because next week we're going to start with a new topic. Okay, I will let people know in the group as well. But if no one has any questions, queries, concerns about these extra classes, about sequences and series, about anything, we can end it there. Okay, so I'll leave it open for like another 2 minutes if anyone has any questions. And yeah, cool. But if no one else, I'll just end it if no one asks questions. So thank you guys so much for joining, and I will see you guys next week.